Hi guys, Mrs. Waymeyer here. Today we're going to talk about prime factorization. So hopefully you've already talked about what a prime and composite number is, but if you haven't, friendly reminder that a prime number is a number that can only be made up of two factors, 1 and itself. For example, 17 is a prime number because its only factors are 1 and 17. Composite numbers are made up of multiple different prime numbers, but composite numbers are made up of more than two factors. So today we're going to talk about prime factorization, and actually all the numbers that we're going to use today are composite numbers, and we're going to take those numbers down to their prime numbers. Now when we do prime factorization, we really don't want to use 1 in our factor trees. We want to try and get down to 2s, 3s, 5s, 7s, 11s, any of those prime numbers, but we are not going to include 1 in our prime factor trees today. So you'll notice my first question is 36. So I'm going to try and find the prime factors of 36. There are a couple of different ways that we could go about making our factor tree. I'm going to start with one and show you a second example, and you should still, if you do the math correctly, get the same answer. So the first thing we have to do when making our factor trees is think about what are two numbers that we could multiply to get 36. For this example, I'm going to start with 4 and 9. So notice that we're building a tree. We're kind of having some branches that are going off here. So this is why they're called factor trees. What I'm looking for is prime numbers. So I notice that 4 is a composite number. It can be broken down into more factors. It can be broken down into 2 times 2. 9 is also composite, so it can be broken down into 2 more factors, and I'm going to use 3 and 3. You don't have to put these multiplication symbols in here. Right now I'm just going to do that so you can kind of see where I'm coming up with them. Now 2's are prime numbers, so we are done. 3's are also prime numbers, so we are done. We have our prime factorization of 36. Our prime factorization for 36 would be 2 times 2 times 3 times 3. We want to list them in order from least to greatest, and it just kind of worked out that our problem did that for us here. But you might have to do some rearranging. So notice that I circled these and I stopped because these were prime numbers. The only thing I can break 3 up into is 1 and 3, and the only thing I can break 2 up into is 1 and 2. Therefore, I know that this is my prime factorization. I could also use math to check myself. Remember, we're trying to break down the number 36. So if you take 2 times 2, you get 4. 4 times 3 is 12. And if I take 12 times 3, I do end up with that beginning number of 36. At the beginning, though, some of you might take a different route. For example, let's say that you didn't use the facts 4 and 9. You want to use the fact 6 and 6, because 6 times 6 also equals 36. Try and make sure I don't run into that one. So if I break these down, this is a composite number. I'm going to break it down into its prime factors. I would break it down into 2 times 3. And 6 can also, again, be broken down into 2 times 3. Now, again, I'm going to write this from least to greatest, so I'm going to have to rearrange a little bit. 2 times 2 times 3 times 3. And now, hopefully you're noticing, no matter which way I started with which fact for 36, I still end up with the same answer. The same answer. 2 times 2 times 3 times 3 will get me the prime factorization for 36. Now, let's move on to 24. There are a lot of different ways I could go for 24. I could do 2 and 12. I could do 3 and 8. I could do, 6 and 4. So there are a lot of different options that we could have for 24. I'm going to go ahead and do 3 and 8. But again, if you're trying this at home and you want to try different facts, you should still end up with the same answer. So I'm going to break it apart into 2 numbers, 2 factors. 3 is prime. So I can actually circle this. I don't want to break it down any further into 1 and 3. However, 8 is composite, so I am going to break that one down further into 2 and 4. Be careful. This is where I have a lot of students that like to do 4 plus 4. 4 plus 4 does equal 8, but when we're working in our prime factorization trees, we're thinking about factors. What numbers can you multiply to get 8? 2 is prime. 4, however, is not. So we're going to break it down into its last 2 prime factors. If I were to write the prime factorization for 24 from least to greatest, I would end up with 2 times 2 times 2 times 3. Now I'm going to check myself. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 does get me that beginning number of 24. So we are good. This is our prime factorization. Moving on to 49. So if I have 49 at the top of my factor tree, 1 times 49 would work, but remember we're not putting 1 into our factor trees. 49 is actually not prime, it's composite. We can use the fact 7 times 7. However, 7 and 7 are both prime. So our prime factorization ends right here in the first step. We don't have to go any further like these first 2 examples. So the prime factorization for 49 is that normal fact we would use, 7 times 7. So they don't always have to be super elaborate or super challenging, although we like to challenge your brain sometimes. 55. Ways to get 55. I'm going to choose 5 and 11. And this is probably the only way that you're going to choose because I notice 5 is prime and 11 is also prime. So, again, our prime factorization ends up being just 5 times 11. So please remember that when you're making your factor trees, you're thinking about factors, numbers that you can multiply to get that number up above. 2 times 4 is 8, not 4 plus 4. Also remember that if you end up with a prime number, you're circling it, you're done. No need to go any further. Last little tip that will help you when we start talking about powers, make sure that you're writing your prime factorization from least to greatest. So putting them in order from least to greatest. Hopefully this video helped you with prime factorization and being able to make your prime factorization trees. Thanks for watching.